Anyway, sampling always involves two groups, a sample and a population. A population is defined as all the individuals of whatever we're examining. And just to define now, individuals are defined as the subjects we're gathering data for, so that can be people, it can be markers, it can be whiteboards, it can be anything. And then a sample is simply just a group of that population that we're examining to get information about that population.
There are many different sample designs, ways to obtain samples, but the most trusted way is to create an SRS or simple random sample. This is basically collecting your individuals in the most random way possible. To give the definition from the book, it is a sample size of n from the population chosen in such a way that every set of n individuals has an equal chance of being selected. An SRS is the best because it minimizes bias, the phenomenon that a study favors certain outcomes, and it's also good to note here that samples should try to minimize variability, which is done through obtaining larger samples. Essentially, by rule, larger random samples give more accurate results than smaller random samples. A census is taking the data of all the population that the data is being collected for. The tool for creating an SRS is the table of random digits. It basically contains a long string of digits from 0 to 9 in a random order.
So there are sampling methods beyond SRS, and they all sort of fall short of the SRS in their own way. Foremost, one could do a voluntary response sample, in which one includes only volunteers in the sample, but this introduces bias. In some cases, individuals who volunteer could be more likely to favor a variable being tested in the experiment. Here we have the kind of sampling listed: voluntary, stratified, and multi-stage, and though there are more, we'll cover these and give examples for them. And the problems that we have in each of these by using these instead of the SRS is bias, undercoverage, non-response, and confusing wording. For example, voluntary response samples also include bias because only the really dedicated actually replies to, for example, a telephone survey. Also, not everybody has access to a telephone, so you will also experience undercoverage when collecting your data. Also, one can divide up a sample into different groups, which is stratified random sampling. Though there are some benefits to this, there exists a flaw, which is that you might not get all the overall average. There might be a different mean, median, and other statistics in each strata that create an unusual feature when put together later. Another similar sampling design is a multi-stage sampling design. It involves choosing smaller groups of samples and stages, leading to clusters. Probability samples can suffer because of undercoverage, non-response, response bias, or wording problems, which lead to less accurate data. Make sure each of these conditions don't interfere with sampling. To obtain your data. One way is to conduct an observational study. This method involves observing a phenomenon and recording that observation. The other way is to conduct an experiment as shown here. First, you randomly distribute into groups and divide into groups, provide each treatments, and then compare each data. As this is an experimental model. And this method involves imposing a treatment on subjects. And the last way is to conduct a simulation. Using known data, you will simulate gathering the sample for testing the hypothesis. Larger samples taken will provide more accurate results than smaller ones. Therefore, the confidence interval, standard deviation, and everything else that could fit is smaller as well. So, the more data you have of a certain subject, the more likely that the sample will be closer to the population mean. And here are some extra terms. As you all probably know, probability is the chance that something will happen. A sampling frame is a list of individuals from which the sample can be taken from. A probability sample is a sample chosen by chance. An exploratory analysis asks what the data tells us about variables and their relations to each other. And last, a statistical inference answers specific questions with a known degree of confidence.